And welcome back to 2.1, the number line from course 1A, Singapore Math. I'm sure you had an opportunity to see the content video for this chapter. If you have done, you are ready to work with me on independent practice. Let's go. Complete each number line by filling in the missing values. It's easy, right? You just have to fill in the missing values based on the values that are already there. So we see here that it's 24 and then it's 25, right? So it's 26 and that's going to be 27. Then we have 28, 29 and 30, 31, 32 and 33. And this is one before, right? So that's going to be 23. And it's done. So this is how you fill in the number line based on the values. Here we saw that the difference is of 1, right? So each dot, each mark on the number line represents a difference of 1, right? So you started counting up by 1. And when you have to do on the left side, you start counting down by 1. Okay, now you see that it's 5.1 and then directly you have 5.2. 5.2 minus 5.1 is 0.1. So that 1 gets divided into how many? Let's see, that's 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So this goes perfect. So this is increasing by how much? 5.1 to 5.2. So you actually have 5.11, 5.12, and you go on like that. Okay, so let's start doing that. So this is 5.11 and this is going to be 5.12. That's going to be 5.13, 5.14, and that's 5.15, 5.16, and that's 5.17, 5.18, 5.19, and 5.2. So we are right in doing the way we did it. Okay. Now in this questions, we are given some situation and we have to figure out, like here, we have find the odd numbers from 11 to 21. So we have to identify, we have to solve that and then plot it on the number line. Okay, so it says draw a horizontal number line to represent each set of numbers. Odd numbers from 11 to 21. You know what are odd numbers, right? So odd numbers end in 1, 3, 5, 7, and 9. So it says from 11. So 11 is also counted. Next odd number is going to be 13. 12 is an even number. 14 is an even number. And next is 15. So it's like you skip one. That's how you do it, right? So 16 is skipped. We have 17. 18 is skipped. We have 19. And 20 skip. That's 21. So these are the numbers. So first you have to solve this and then you plot it on the number line. So now we write these numbers here. So we start from here, 11. So that becomes 13. This will be 15. That's going to be 17. That's 19. And that's 21. Right? So you take your ruler, draw a number line and mark 1 centimeter as 1 unit. Okay, so I'll just show one over here and then you should be able to do each time without me showing the number line. So it's basically you start from here, right? So we say this point here, right? So that's point 1. Then you leave 1 centimeter, that's the next one. Leave 1 centimeter, that's the next one. So that's how you mark your units, okay? So that I've already done that job here. You just have to then plot the numbers. So you know how to do this number line now. Draw a horizontal number line, which we have it here, to represent each set of numbers. Positive whole numbers less than 9. The whole numbers means they do not have decimals. They are not fractions. They're just simple numbers like 1, 2, 3, 4. Okay. So whole numbers less than 9. So it starts with 1. 1, 2, 3, 4, 5, 6, 7, 8. And 9. Do we include 9? We don't because it says less than 9, right? So it should be less than 9. So these are the numbers that we need to plot on the number line. So we start with 1 here. 1, 2, 3, 4, 5, 6, 7, 8. Yes? It's easy. It's just that you need to be able to solve this part very well. Once you have this, plotting number line is very easy. Read that question thoroughly. Whole number greater than 12. So your 12 should be less than that number, right? But less than 18. So it means that number should be less than 18. So greater than 12, less than 18. So what are the numbers? So it's basically you have all the numbers between 12 to 18. So what are these numbers? 13, yes, it's greater than 12, but less than 18. 14, 15, 16, and 17. 18, of course, not, because 18 would be equal to and not less than. So these are the numbers that we need to plot here. So we say 13 here, 14 here, 15 here, 16 here, and 17. That's it. Easy. Let's go for the next one. Mixed numbers. Now we have mixed numbers between 0 and 2 with an interval of 1/3. That's the interval between each pair of numbers. So it has to be between 0 and 2. An interval is of 1/3. So let's say the first one is 1/3. What's the next one? The interval has to be 1/3, right? So it's basically 1/3 plus 1/3 is what you do. So you get both the denominators are same. So you can add. So it's 2 upon 3. So the next number is 2 upon 3. What's going to be the next one? You can predict now, right? Of course, it's going to be 3 upon 3. And 3 upon 3 is actually 1, right? That's a whole number there. And you want to check here, you can see 2 upon 3 plus 1 upon 3. Denominators are same. So denominator as it is, 2 plus 1 is 3. Right? So that's how you get it. So now you know you have to go up to 2. So the next is 4 upon 3, 5 upon 3, 6 upon 3. Now what is this 6 upon 3? 6 divided by 3 is 2. So it is between 0 and 2. Okay, so we do not go further than this. So we are not even going to represent this number because that's 2 and it says between. So it has to be less than 2, right? So let's plot these numbers. We have 1 upon 3, 2 upon 3, 3 upon 3, 4 upon 3, and 5 upon 3. Yes? Easy? Ready for the next one? Or you want to do it by yourself? Please go ahead. Decimals from 7.0 to 8.4. So it's from, which means we will include 7.0 and to 8.4. So we'll include 8.4 as well. With an interval of 0.2 between each pair of decimals. So we are plotting decimals on this number line. And we will begin with 7.0. Now it says the interval is of 0.2. So it's 7.0 plus 0.2. So that's 2 and that's 7. So the next number is 7.2. So each number will go up by 0.2, right? So I'm sure now you know what are the numbers. You don't need to do this addition each time for each number, right? Because we are smart. So the next one is going to be 7.4, then 7.6, 7.8, 8.0, 8.2, and 8.4 because that's the last one here. We already have the numbers. Let's just put them on the number line. So that's 7.0, 7.2, 7.4, 7.6, 7.8. Next is 8.0. Then we say 8.2 and here 8.4. So these are the numbers that we need to plot on this number line. Here comes the next one. Now we have a vertical line. So we have it here. Even numbers between 20 and 32. Remember this word between. So are we going to include 20 and 32? No, we will not include them. Okay. In the previous one, it was from and to. So we included them. But this one here says between. So we'll include numbers between that limit and not those numbers. So we start our numbers from 22, right? What's the next one? Even numbers, 24, 26, 28, and 30. And now we plot them. For the vertical line, we start from the bottom, right? So that's 22, then that's 24, 26, 28, and 30. So that's how you plot numbers on the vertical line. Ready for the next? Again, vertical line, and it says positive whole numbers less than 13. It's positive whole numbers less than 13. Okay, so you have to start from 1, right? So 1, 2, 3, it will go all the way to 12. They're whole numbers, no decimals, no fractions, and they're positive. So we start from 1. Okay, I'm not writing the whole list because you have to go up to 12. So that's 1, that's 2, that's 3, that's 4, that's 5, that's 6, that's 7, that's 8, that's 9, that's 10, 11, and 12. I like to write on both the sides so there's neatness on the line. Again, a vertical line, whole numbers greater than 6. Okay, so we write the number that is greater than 6. So 6 has to be less than that number, right? But it has to be less than 16. So the number is greater than 6, but is less than 16. So you know what numbers will be there, right? So 7, it's greater than 6, yes. It's less than 16, yes. Then 8, and the list will go on until which number? Until 15, right? Because 16 cannot be included. 16 is equal to 16 and not less than condition will not be applicable. So we start plotting here. That's 7, 8, 9, 10, 11, 12, 13, 14, and 15. And it's done. These questions are going fast, right? Number line plotting, if you have to draw and all, it's going to take you a little time. So when you're drawing that, you can pause the video, draw it, and then plot with me. Positive fractions. So now we are going to talk about the fractions here. They're positive. Less than 1. Okay? With an interval of 1/8 between each pair of fractions. So they are positive, they are fractions, and the interval between the two fractions is of 1/8. So we start with 1/8 as the first one. What's the next fraction? To get the next one, we have to do 1/8 plus 1/8 because that's the interval between two fractions. So that's going to be, this 8 remains as it is. Both the denominators are same, so you can add directly, right? So that's 2/8. The next one is, yes, you know it, 3/8, 4/8, 5/8, 6/8, 7/8. Do we go further? Let's see. Next one would be what? 8/8, right? And 8/8 will be what? It gives a whole number of 1. But it says less than 1. So this is not included, right? So let's plot them now. 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, and 7/8. Easy? And here comes the last one. It says decimals between 10 and 15. 10 and 15, and it is between. With an interval of 0.75. Interval is of 0.75. So it's between. So 10 will not be included, right? So 10 plus 0.75 is going to be 10.75, right? Check it here. 10. So it's 0.0. Nothing means 0.0, right? 0.00. And we say 0.75. That's the interval that we have, right? So that's 5, that's 7, 0, 0, and that's 1, right? So it's 10.75. And then next is going to be, let's add here 0.75 to this. That's 0, 1 carry, that's 7 plus 7, 14, plus 1 is 15, 1 carry, that's 1 and 1. So that's 11.50. Then we do 11.50 plus 0.75. That's 5. That's 12. 1 carry, that's 2, and that's 1. So it is 12.25. Then we do 0.75 again. That's 0. 1 carry, that's 3 and 7, 10. So 0. 1 carry, that's 13. Next is 13. Now you see the pattern. We started with 10, so that became 10.75. Now we have reached a whole number again, 13. So next one is going to be 13.75. Next one will be 14.50. Okay, and next one is going to be 15.25. But we said between these two numbers, and this is greater than 15, so we don't include this. So these are the numbers that we need to plot here now. So we start from here, 10.75, then we have 11.50, that's 12.25, that's 13, then you have 13.75, and finally 14.50. Right? Good so far? Enjoying? Great. Okay, for the next few questions, what I've done is I've already plotted number line, and I'll explain you how I have done that. Now you have to compare each pair of numbers using this sign. So it's basically you have to put this less than, greater than symbol between the two numbers that's given. And it says draw a number line to help you. Okay, so we actually don't need a number line because the numbers are pretty simple to interpret. But if you need one, it's already here. Now, 2, 3 7, and 9 7. These are the numbers that you have. 2, 3 7, and you have 9 7. Now 9 7 can be written as what? It can be written as 1 2 7, right? Because 9 divided by 7, that's times 1 is 7, and 2 is the remainder. So this 1 becomes here, and remainder goes here, and that's your divisor. So that's how you write it. Now look at the numbers. This is number here is 2, and that number there is 1. And this here 7 7, so that's okay. So we can just, by looking at this, we can easily say that 2 3 7 is greater than 9 7, right? It's that simple. So we say this is the answer here. And even if you look at the number line now, I started plotting from 1 upon 7. So 2 upon 7, 3 upon 7, because the denominator is 7, right? So I went from 1 upon 7. So this is where it comes to, 9 upon 7. So I've already put double line here to indicate this is the number that we are looking for. And this one here is 17 upon 7. So if you do the reverse work with this, so this is 2 times 7 plus 3 upon 7. That's 2 times 7 is 14. 14 plus 3 is 17. So that's 17 upon 7. And that's exactly what we have here. So you see one number is here, the other one is here. But obviously 9 upon 7 is less than 17 upon 7. So you do either of the conversions, okay? Next one, 17 upon 25 and 1 7 upon 25. So these are the numbers, 17 upon 25, 1 7 upon 25. Now look at this one. This one says that it's already 25 upon 25. And you still have 7 more. So that's going to be 32 upon 25. So is this or this bigger? You know what is bigger, right? So this one is smaller than this. That's how you do it. It is that simple to decide, right? Even if you look at the number line here, I started with 17 upon 25. And then I converted this. This becomes 32 upon 25, right? Because 1 times 25 plus 7 upon 25. So that's 25 plus 7 upon 25, which is 32 upon 25. And that's what you have it here. So which one is smaller? 17 upon 25. Okay, so I have all the numbers on the number line. Next, now here you have different numbers. So 1 and 1 is there, but this is 4 upon 5 and the other one is 2 upon 3. Then how do we compare? So we will do 4 divided by 5. 5 does not go in 4, so we put 0 and we put a decimal here. 5 times 8 is 40. So this is basically 1.8, right? Because 4 upon 5 is 0.8. And similarly, we do 2 divided by 3. It doesn't go, so we put 0 and the decimal here. 3 times 6 is 18. 2 remainder, again 0, and it will go on. So this is basically 1 point, that 1 this one, and 2 upon 3 is 6 bar, right? Because it's repetitive. So which one is bigger, 0.8 or 0.6? 0.8 is bigger, right? So this one is greater than the other one. So 1 4 upon 5 is greater than 1 2 upon 3. So if you look at the number line here, I have 1.6 here, right? 1.8 is here. So this is exactly what I want. And now this is 1.666. Actually, it's repeating, right? So it will be somewhere here. Not this one, but it's going to be somewhere there. So which one is smaller? You can see from the number line also. This one is very simple because it's 33 and that's 36. Do we need to even work on this? This is how it's going to be, right? So 33 is here, 36 is here, and this is 36 point something, and this is 33 point something. So 33.61 is less than 36.13. Here comes the next one. Both are 59 and 59. The decimals differ. The decimal is 0.5 and the other one is 5. So which one is bigger? But 0.05 and 0.5, which one is bigger? This one, right? So we know that this one is smaller. So let's look at the number line here. What we have done? 59, 59.05, 59.10, right? And then we go on and this is 59.5. And the final one on this. 98 and 98. Now both are 98. So let's look at the decimal digits. So it's 0.072 and that's 0.027. So first we look at the first decimal digit. 00, we can't decide. Let's look at the next one. 7 and 2. Which one is bigger, 7 or 2? 7 is bigger, right? So this is bigger and that's why this is also bigger. Now even if you look at the number line here, 98.01, 98.02, and likewise I've gone up to 98.07 and 98.02 is here. So which one is bigger? The one on the right hand side, right? So it is decided. Now we have some different set of questions. It says draw a horizontal number line from 2 to 3. Okay, so that's defined for us to represent each set of numbers. The numbers are given to us and the numbers are mixed fractions, right? So all of them have 2 and then 4 upon 5, 3 upon 20, 1 upon 2, 11 upon 20, 9 upon 20. How do we do this? Now I'm going to solve this question in 2 ways. Choose the one that works best for you. Now first is based on something that we have learned in the first chapter about the LCM, least common multiple. So do you see the denominators? 5, 20 and 2. These are the denominators that we have. So we will convert this denominator into a number that's equal for all of them. And how do we do this? For that we use LCM. So we write 5, 20 and 2. So let's start doing the LCM. I'm sure you remember it, right? We'll start with the smallest prime number, which is 2. 5 as it is. 20 divided by 2 is 10 and 2 divided by 2 is 1. Again we go with 2 because we have 10 there. 5 as it is. 10 divided by 2 is 5 and that's 1. And now we go with 5. That's 1, 1, and 1. So our LCM is this, right? So that's 2 times 2 times 5, which is 2 times 2 is 4, 4 times 5 is 20. That's the LCM. So each of this fraction should have 20 as the denominator. So how do we do that? Now in first case, we have 4 upon 5, right? How do we make 5 as 20? 5 times 4 makes it 20. If I multiply my denominator with 4, I also have to multiply my numerator with 4. So that's 16 upon 20. So the first fraction that we have here, we write it as 2 16 upon 20. Okay, and that's 2 4 upon 5. Let's do the next one now. We have 3 upon 20. That's done. We don't need to do anything with that. So we are going to write that as it is. 2 3 upon 20. We go for the next one. So that's 1 upon 2. We have to make 2 into 20. So we do 2 times 10. And of course, 1 times 10. So that's 10 upon 20. So we write this as 2 10 upon 20. Which one is it? It's 2 1 upon 2. Okay. Then again, this is already 20. So we just write it down. 2 11 upon 20. And the last one is already 20. So 2 9 upon 20. So these are the numbers that we are going to plot. Now do you see? The 2 is common in all of them. So we don't need to worry. The denominator is 20 in all of them. So we can easily compare the numerators now. And it's very easy to plot on the number line. So we have 1620, which is here. Okay. Then we have 3 upon 20. So that's here. Then we have 10 upon 20. Then we have 11 upon 20 and 9 upon 20. Okay, so now the first one, 3 upon 20 is already in this format, right? So I'll just leave it as it is. Then 9 upon 20 also in the same format. Then 10 upon 20 was this. So it's actually 2, 1 upon 2, right? 11 upon 20 as it is. And 16 upon 20 was 2, 4 upon 5. So this is how I plot them on my number line. By finding LCM, equalizing the denominators, you were able to then compare and plot them on the number line. So that's one method. Okay, let me show you the next method for the same question. In this, what I'm doing is, because it all has 2, I'm going to leave that 2. And now each fraction, I'm going to convert it into a decimal form. So we say 4 divided by 5. It doesn't go, so we put 0 and the decimal here. 5 goes 8 times in 40, and that's 0. So this is 0.8, right? So this becomes 2.8. Okay. Next is 3 upon 20. So I do 3 divided by 20. It doesn't go. I put 0 and I put a decimal here. It goes once. That's 20. 10 is the remainder. We put another 0 and that's 5. And that's 0 there. So this fraction becomes 2.15. Right? And 1 upon 2, do you really need to do the calculation? You know that it's 0.5, right? So that's 2.5. Then we do 11 divided by 20. It won't work, so we put 0 and a decimal there. 20 times 5 is 100. 10 is the remainder. Another 0, and that's again 5, and that's 0 there. So this number here, it becomes 2.55. And the last one we have is 9 divided by 20. So 0 and a decimal there. That's 4 times 80. 1 0, again 0, and that's going to be 5 times, right? So that number here is 2.45. Now I have all my numbers in decimal format. For us to compare numbers, it's always good to have them in the same format. And we put them in the number line here. So first one is 2.8 here. Where is our 2.8? This is 2.8. Then it's 2.15, which is here. 2.5 is here. Then 2.45 is here. And 2.55 is here. Okay, 2.15 is what? 3 upon 20. And then 2.5 is for 1 upon 2. 2.45 is for 9 upon 20. 2.55 is 11 upon 20. And this 2.8 is 4 upon 5. Right, so this is how I can plot them on the number line. So it says, draw a horizontal line from 2 to 3 to represent each set of numbers. So this, I've drawn a number line, but I've not marked 2 here. So this is somewhere here you will have 2 and somewhere here you will have 3. Now all the numbers are in a decimal format, so it's easy to compare and plot them, right? So this is 2.125. Then 2.250, I've taken a difference of like 0.125. I'm marking up each time with that, okay? So 2.50, then 2.375 is what I have to mark. And then 2.500, that's what I have to mark. So 2.5 or 2.500 is the same thing. And I mark up and then I go 2.625, then 2.750, and finally I reach 2.875. So this one was a very easy one, right? Because it's already given in the decimal format to us. So it was just rearranging and putting them on the number line. So it was that simple. Okay. Now it says you have to mark from 0 to 1. Well, I've not marked 0 to 1. If you want, you can like further extend this line, and somewhere it's going to be 0, and extend this line further, it's going to be 1. Now here 1 upon 3, 1 upon 4, these are again fractions and they do not have the same denominator. So one of the methods would be to convert it into decimal format and plot it. I'm going to show the LCM method here, but I expect you to do the decimal format and solve that question by yourself and see whether our answers match or not. So first I'll find the LCM. I have 3, 4, 8, again 4, again 8, and then 6. So these are the numbers that I need to work upon. So that's 3, 4, 6, and 8. I'm putting them in the sequence. Let me start with 2. 3 as it is. 4 divided by 2 is 2. 6 divided by 2 is 3. 8 divided by 2 is 4. Again 2. That's 3, that's 1, that's 3, and 4 divided by 2 is 2. Again, we go with 2, that's 3, 1, 3, and 1. Now it's just 3, so we divide with 3. Then that's 1, 1, 1, so we stop here. So this is our LCM. 2 times 2 times 2 times 3. So that's 2 times 2 is 4, 4 times 2 is 8, and 8 times 3 is 24. So our LCM has to be 24. Here we are going to convert each of the denominator into 24. So that's the next step for us. So it's 1 upon 3. For 3 to become 24, we need to multiply with 8. So this is what we do. So that is 8 upon 24. The next one, 1 upon 4. 4 to become 24, multiply with 6. So that is 6 upon 24. And then we have 3 upon 8. 8 times 3 is 24, right? So we multiply with 3. That's 9 upon 24. 3 upon 4 again. So we multiply with 6. So that's 18 upon 24. Then we have another one, 7 upon 8. So that's times 3, right? Because we have to make the denominator 24. So that's 21 upon 24. And finally, 5 upon 6. That's times 4. That's 20 upon 24. So now you see each one of them is 24. Right? So now it's easy for us to compare them. and it's easy for us to put them on the number line. So let's look at the number line. Do we have 8 upon 24? This is 8 upon 24. Then we have 6 upon 24. Then that's 9 upon 24. Next one is 18 upon 24. 21 upon 24. And finally 20 upon 24. So this is how we plot it on the number line. Now I've done using LCM method. I suggest that you do decimal format for this and solve and see do you get the same representation or not. I'm sure you will be able to do it. You are confident, right? I'm confident that you can. So go for it. Well, I'll just give you the answer for the decimals. I'm not plotting it, just giving you answers for you to check. So 1 upon 3. The answer for this is 0.33. 1 upon 4 is 0.25. 3 upon 8 is 0.375. 3 upon 4 is 0.75. 7 upon 8 is 0.875. And the last one, 5 upon 6 is 0.83. Did you get this? If you did, amazing. You know it now. This was for your reference. Plot it and it's going to be the same, exact same as we had with LCM method. Okay, ready for the next one now? It says draw a horizontal line from 0 to 1. So extend this further, it's 0.05, right? So 0 is somewhere here and 1 is already marked up. And these are all decimal numbers, easy to mark them, right? So 0.1 is here, 0.25, 0.05, 0.8, 0.75, and 0.95. And it's done. So each one is at a distance of 0.05. Okay, that's my unit. So every centimeter I've taken 0.05. So if this was centimeter 1 here, then this is 2, 3, 4. Likewise, I've gone ahead, increasing by 0.05. Okay, so this horizontal line is done with that. Compare each pair of numbers again. So we have to compare them and draw a number line to help you. So 0.8 and 1 upon 10. Always good to have one format, right? So 1 upon 10 is basically 0.1. So which one is bigger? Of course, 0.8. So 0.8 is here and 0.1 is here. So 0.8 is bigger than, greater than 0.1. 1 upon 5 and 0.25. 1 upon 5 is 0.2. You can solve here. That's 1. It doesn't go right. So we put 0 and we put decimal. Remember, your decimal is important. Don't you forget that. 5 times 2, 10. That's done. So that's 0.2. So what is bigger, 0.2 or 0.25? So 0.2 is also like 0.20, right? So 0.2 is here, 0.25 is here. So this is the symbol. Here comes question 26. 3 upon 5 and 0.3. So 3 divided by 5. 0 and the decimal 5 times 6 is 30. So this is 0.6. So which one is bigger, 0.6 or 0.3? 0.6. So 0.6 is here and 0.3 is there. So even on the number line, you can see which one is bigger, right? Next, 0.14 and 1 upon 4. Again, 1 upon 4, right? 0, decimal, that's twice, that's 8. 2, 0 again. 4 times 5 is 20 and that's 0. So 1 upon 4 is 0.25. What's bigger? You check the first digit here, right? 1 and that's 2. So which one is bigger, 1 or 2? 2, right? So this is the symbol. So 0.1 is here. Do you see? And 0.25 is here. So 0.1 is here and that's 0.15. So 0.14 would be somewhere here, right? So you know what's bigger, which number is greater and which one is a smaller number. 2 upon 5 and 0.25. 3. So 2 divided by 5. 0, that's times 4, 20, and done. So that is 0 0.4. 0 0.4 and 0 0.3. This one. Look here, 0 0.3 and 0 0.4. So this is what it should be, right? 0 0.64 and 9 upon 10. 9 upon 10 is 0 0.9, right? Divided by 10 is easy. You shift the decimal, right? So first digit here, we compare the first digit. That's 6 and that's 9. So of course, this is smaller. So 0.6 is here and 0.9 is here. So 0.65 is here. So 0.64 would be somewhere here. 0.2 and 1 upon 6. So 1 divided by 6. You put 0 and you put the decimal. 6 goes 1 time. That's 6. 4. And then again 0. That's 40. So it's 6 times. That's 36. 4. So it will go on. Like the process will go on, right? So it's 0.16 with a bar. That bar means 6 will keep repeating. So we compare the first digit after the decimal. That's 2 and that's 1. So which one? This way, right? So 0.16 is here and 0.2 is here. And this is 0.17. So 1666 would be somewhere here, right? And the last to compare, 7 upon 8. 7 divided by 8. That's 0. That's times 8 is 64. 6 remainder, again 0. That's times 7 is 56. 4, 0. 8 times 5 is 40. So this is 0.875. And this is 0.87. So when it's 87, you put 0 here, right? If you want to make it 3 digits. So first 2 digits, same. So we compare the last digit, 0, and that's 5. So, but obvious the 5 will be larger, right? So it's 0.87 and 0.875. Now, here comes the word problem. The wingspan of one butterfly is 9/16 inches. The wingspan of another butterfly is 5 upon 8 inches. Write an inequality comparing two wingspans. So we have one 9 upon 16 and the other one is 5 upon 8. How do we solve this? Now, 16 and 8. Do you see 8 goes in 16? Like 16 is a multiple of 8. So we'll try and make 8 as 16. And for that, we know what we have to do, right? So that's 8. How do we make it 16? By multiplying with 2. So that becomes 10 upon 16. So this number can be written as 10 upon 16. And we write this number as it is over here. Now see which one is greater. 1, same. 16, same. What is different is your numerator here. So 9 upon 16 or 10 upon 16? Of course, this way, right? So this one, 5 upon 8, is a larger one. So inequality sign is going to be this way. 9 upon 16 is less than 10 upon 16. Or if you want to go back here, do it here. So 9 upon 16 is less than 5 upon 8. Like you convert this, you get this answer, but your final answer should be this always, because that's what you are expected to compare. And now comes the last question. For a class project, Jacob made a model of the Empire State Building that was 23.7 centimeters tall. Okay, so we have Jacob who makes the model of 23.7 centimeters. His friend Danielle, Danielle, made a model that was 23 upon 5 centimeters tall. Whose model was taller? So we need to find whose is taller and how much taller. Okay, so we don't just find which one is taller, but which one is taller by how much. Now, one is a decimal, one is a fraction. Difficult to compare. So we'll make both as decimals, okay? So this is already decimal and we leave it there. So we do this one. That's 3 divided by 5. So we put 0 and that's a decimal. 5 times 6 is 30. So this one is actually 23.6 centimeter and this one is 23.7 centimeter. So which one is bigger? Of course, this one, the Jacob, right? Whose model is taller? Jacob's model is taller. You will write the whole sentence, okay? Jacob's model is taller. And then it says how much. So, do you need my help here? How much? So you do larger minus smaller, right? So 23.7 minus 23.6. 7 minus 6 is 1 and this is all 0. So Jacob's is taller, right? Jacob's model is taller than whom? Then Danielle. By how much? By 0.1 centimeter. Only 0.1 centimeter. Okay? And it's done. And the chapter is also done. How did it go? Just understand number line. And if you are still not comfortable with number line, I would suggest that go and watch content video. Come back again to the independent practice and solve again with me. And you will be really getting good at it because you're practicing enough. The more you practice, the better you get at it. So keep practicing, keep watching, keep solving with me so that you don't feel alone. If you feel, oh, it's too much, you're alone, come back, watch, solve with me, and we'll be always together. And together, we will get good at math. More the merrier. So keep solving and keep enjoying math. See you in the content video for the next chapter. Until then, have fun.